Welcome to Session 17, Coordinate Plane Basics. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to plot ordered pairs by moving in X first and Y second, identify axes, origin, quadrants, and the signs used in each quadrant, find horizontal and vertical distances without a full distance formula. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The coordinate grid shows halfway positions in ordered pairs. The horizontal and vertical changes create measurable distances. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. The points minus 3, 2 and 5, 2 lie on the same horizontal line. Their distance is 5 minus 3 equals 8 units. The equal y values show immediately that no diagonal calculation is needed. Coordinates are addresses, horizontal movement changes x, and vertical movement changes y. Signs determine direction, and axis points belong to no quadrant. Label the right angle, the ordered pairs, or the changes before substituting. A diagram that records structure reduces sign and side selection errors. Now add a precision check. Choose an order for the 2 points and keep that order in both coordinate differences. A quick sketch should show horizontal change, vertical change, and any right angle. Simplify exact roots before rounding and check whether a negative, 0, or undefined slope matches the graph's direction. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, start at the origin and move right for positive x or left for negative x. Second, then move up for positive y or down for negative y. Third, for horizontal points, subtract x values. For vertical points, subtract y values and use a positive distance. Finally, read the plotted point back to yourself in x-then-y order. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. Which point is in quadrant 3? Step 1 is to organize the information. Start at the origin and move right for positive x or left for negative x. Step 2 chooses and sets up the relationship. Then move up for positive y or down for negative y. Step 3 carries out the mathematics. Quadrant 3 has negative x and negative y. A useful check is to coordinates are always written x, y. The answer is -3, -5. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. What is the vertical distance from -1, 3 to -1, 10? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 7. Only y changes, so the distance is 10 minus 3 equals 7. A useful check is to coordinates are always written x, y. Use this coaching check as well. Use the phrase across, then up or down to prevent reversing coordinates. Session recap. First, start at the origin and move right for positive x or left for negative x. Next, then move up for positive y or down for negative y. Then, for horizontal points, subtract x values. For vertical points, subtract y values and use a positive distance. Finally, read the plotted point back to yourself in x-then-y order. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.